Tim. I work at Wooga as a backend engineer. So we don't call ourselves DevOps either, but this is effectively what we do because we do not have any other operations people. So we have the Amazon philosophy that for each we have lots of teams, but each team is independent. And each team works on one game only and does everything: development, operations, maintenance, whatever. Yeah, I'm going to talk about dashboards today. Initially, I wanted to call the talk dashboarding. Then I thought maybe this sounds too much like torture, right? And it's, as I said, it's a dry run for my Velocity presentation, which I'm very happy that now I applied 3 years in a row, and now finally I was accepted. But I'm very happy if you could give me some feedback afterwards, like what I can still improve, because it's 2 months to make it even better for really large audience. Yeah, dashboard. So I brought examples. We have lots of dashboards in we have lots and lots of dashboards in Wooga. So I just went around with my iPhone and took some pictures. This is the one you see when you come in. It greets you at the entrance. And it shows the most high-level metric that we track, which is how many people played our games yesterday, 10 million, and how many people played in the last month, 44 million. And sort of like the highest level metric we have is the game developer world rank, and we are number 2 behind Google. Zynga. We want to be Zynga. We want Zynga to be number 2 behind Google, but okay, we're still working on that. Then we have in the support area, I found this one, which I hadn't even seen before. So they put this up recently, I think, which shows the rank of our iPhone and iPad apps in the App Store. Could be better. I mean, could be in the top 10, but not yet there. Then I found this one in one team room. I don't know what it actually shows, but it looks good. It's all green, right? So it cannot be bad. Right next to it, there was this one. Okay, the information volume is pretty low. Then we have Mania, of course, as well. So we have lots of different. It's a whole it's because the teams are independent, so each team just does what it thinks necessary, or what it thinks could be helpful. So this one team is using Moonion. Then right next to the Moonion screen, I saw this. So this is more specific metrics for the game. So unique users in the upper right corner, current sessions in the upper left corner, and then I think they are tracking errors per minute or something. It's the 0.1%. Unfortunately, it's not there anymore. But when this game launched, on the same screen they had sort of like a faces wall. They showed the avatar of every user who was currently playing. It was super nice to just launch the game. Then you can actually see the people who are interacting with the game. Yes, this is for the mobile app, also a high-level thing. I mean, we do not actually have as a dashboard on the wall, so I just took a web screenshot. So in this case, it shows for the last 3 days the logins installs per minute, just so you can easily see that it's a typical daily curve. Normally the peak is, for us, for our games, the peak is normally in the evening. Yeah, this is the same thing, but just incoming requests on the tracking server. I will talk a little bit about our infrastructure later and explain, because this tracking server has a very central role. And so at peak we have currently around 5,000 incoming tracking requests. This is also looks very simple. It's a very simple dashboard. It's actually the first one I ever built for the first game, Happy Hospital, I built at Wooga. And it shows just the number of people who are currently playing. And we had this up on the wall for a year, and we always, like, it was always visible, and it was, so after a while you get very much used to what is a normal number. Like you come back from lunch and then you know that it's supposed to be 2,000. You come back from lunch and it's 500 and something is wrong. Or you come back from lunch and it's 3,000 and you're, oh, we did something right. We watched this number very closely when each time we deployed, because then we would also, there was like sort of like a typical, it would crash for half a minute, because everybody would have to reload. And then, so we would sort of like look at the dashboard, okay, it's 4,700, let's deploy, and then pray that it will be the same number or higher in a minute. If not, then we have to look into it. And then finally, the most important dashboard of all, the party dashboard. So our CEO gave us, at the beginning of this year, he gave out an official target. And he said, okay, if we reach this target by end of April, we'll have a big party. And you can see the relevant line is the pink line, and we are at 98%. So, and actually the line, I took this photo yesterday, it crossed the threshold today. So there's going to be a big party next year. But I think this is also, it's a very good illustration why dashboards are important. Because not only did the CEO give out this target, but it was also a big switch from the last target. So the old target last year was basically get as many users as possible. We want as many people to play our games as possible, and not worry about making money too much. And now the shift in 2012 is, okay, now we do want to make money, which is a pretty big shift, right? So to drive this point home, I think this dashboard was very important, because it's one thing just telling, okay, so we want to increase monetization, blah blah blah. But I mean, it can only happen if everybody in the different teams works towards this goal. And I mean, this is right next to the exit door. So each time you leave the office, you look at it and say, oh. For example, I mean, okay, in the beginning it was sort of like increasing, everything's fine. There was this big jump and nobody knew what had happened. So we still are not really sure what happened. It was probably related to Apple featuring us in the App Store, and then we had a big increase in mobile revenue. But then it's sort of like crashed. And then these 2 weeks, the mood was really depressed in the whole company. We said, everyone, also the CEO was not very happy about this development. And of course but then he also communicated to us, okay, so you want the party, so please make sure that the line goes up again. And it did. Yeah, so that's just some examples. And now the main part of my talk, I want to talk about technologies we are using for creating dashboards, because we have recently, so in the winter, we have introduced Kafka, and that's a very interesting setup.
Can I ask you something?
Yes.
You said what all these dashboards show, but why do you have these dashboards? Because just to show a big number, or to show, like, we're going to have a party this year, that's okay, but what is the actual, we need these dashboards for?
Well, I think, in my view, a dashboard is, I mean, the word dashboard comes from a car, right? The dashboard is what you have in the car. You see what speed the car is currently doing, how much fuel is left. And when you have a web company, basically it's like a car and you're driving blind, right? You're just driving happily along, but you have no idea what's happening out there. And this is why you need dashboards. You need instruments that tell you what is happening in the outside world, how people interact with what you are doing. And so, yeah, I mean, they have different functions, obviously. I mean, some are very technical and they will just put up by a team because they want to, I don't know, they want to monitor one parameter very closely. And others are more high level, like the party dashboard, which is sort of like a high level goal for the whole company. But still, we want to know how we are doing related to this goal.
And they all, and everybody can look at them?
Yeah, they're all.
Anytime?
They are all open. Yeah. So we also have this sort of like it's sort of like company policy that everything is pretty much open. So also the team meetings are at fixed times every week, and everybody can come. Everybody who's interested can come and get an update about what happened the last week in this game. Or not. If you're not interested, you can. You're not. It's not mandatory.
My question was actually with that, with the meaning behind what I said at the beginning, that DevOps is a mindset, and you said that we do DevOps, and actually that's the point. DevOps is about collaboration, and having all this open to everybody is showing them you can look what we do. You can talk to us if you think something is broken, and that's actually the point.
It could also be the case that like the developers are out for lunch, and when they come back, somebody takes, look, something is wrong. Look at this doesn't look good. And no, this is not a problem because we changed something that's supposed to. We knew this was happening. Oh no, this is really you're right. This is totally wrong. Yeah. Okay, and now for the technology part, I want to do also sort of like an experiment. I want to use the electronic whiteboard. Let's see how this goes. So, the tracking system. So this is sort of like, the thing is, we have a very, the whole ecosystem of technology we have at Wooga is very diverse. Because each team also makes their own choices, right? So one team decides, let's build this in Ruby and use MySQL. And the other team says, no, no, totally not. Let's do it in Erlang and use S3 for the data. And so we have a very, there are not many similarities. It's not a big problem because each team is also responsible for keeping the stuff running. But there's one piece, there is actually one piece of shared infrastructure, and that's the tracking system. So it was decided from the start that it makes sense to have all the data about the games in a central place, so it's open for analysis. So it's like this. So let's say there's this game A somewhere, there's game B somewhere else. They're also hosted in different places. So this A could be hosted on Amazon and B could be at Hetzner, for example. And the players are just interacting with the games. But then we have this central system, which is the tracking system. And it's also very simple. Hey, yeah. Please correct me if I say something wrong. The tracking system is just basically just an HTTP server, and you can make calls. And the calls, you can make any call you want. It's completely open, and it will just be logged. The parameters you send will just be logged. And then, of course, we have some conventions, like we have conventions how which calls the games have. Like they have one call when a user logs in. One call when a user signs up, one very important call when a user spends money, and so on. And they are sort of like at least similar between the games, so it's easier to aggregate the data. And so the old system we had in place for the last 2 years. This tracking system is just it was 3 Nginx boxes, and they were just logging. They were just returning an empty GIF and saying okay. And writing the access logs, and then at night a cron job would pull the access logs and sort of aggregate them and insert them into a database, MySQL. So that's the old flow. And I mean, it's really super simple, simplistic even. But it worked surprisingly well and for quite a long time. But then once the traffic was growing, there were more and more games, so the access logs would be bigger and bigger. So at a certain point, so the main use for this data is we generate a daily report for each game. How did the game do yesterday compared to the day before, and the week before, and the month before? And so ideally, you want this report in your inbox when you come into the office in the morning, right? Because then you get direct feedback. And so it was like over time, the emails were coming later and later. Sometimes they would come in the afternoon, shortly before you would leave the office, which is not good. Because then the reaction time gets much longer, right? You do a change on Wednesday, but you you only get the result maybe Thursday afternoon or maybe even Friday afternoon, because it was maybe the deployment was when it was Wednesday evening. It would take a whole day of data collection and then a whole day of processing. That's much too long. So the main goal for changing the system was to make it more responsive, to make also to maybe to switch from batch processing to something not super real time, but near real time, or more responsive. So what we did is we still have the same. The tracking servers are still the same. It's still 3 Nginx boxes, but now we do. They also still write the log files just as a backup. But the main thing is we put the data into a messaging system. This is Kafka. So this works by the Nginx boxes just have a Perl Kafka client running, and so they keep a TCP connection open and just push each hit on the web server as one event into Kafka. Okay, and now I'm going to go a little bit deeper into what Kafka is and how it works, because it is, I mean, it's basically it's a message broker. So you could also think like something like RabbitMQ or ActiveMQ or whatever, but it's a bit special. So Kafka was built by LinkedIn, and it is a message broker that's optimized for very high throughput, because they use it basically for aggregating metrics. If you want to put lots of metrics in there, you really need high throughput. So the way it works, you can have on the server you can configure a number of topics, and it's just flat. There's no hierarchy. You have topics, and when you push an event, you can say to which topic it goes. That's basically it. And all that Kafka does is, it does two things. It lets you subscribe to the stream of events, and it keeps the events persisted for a configurable amount of time. So, and the second is the most important part, I think, because this is something that a lot of the other messaging systems do not do very well. And in Kafka, it's sort of like the default. You cannot have a non-persistent queue. Every topic is persistent by default. And it's optimized to still offer high throughput, although everything is persistent. And this gives, in the result, gives very nice features. Because conceptually, Kafka gives us this, what I call an event bus. Right? The events come in from the outside. Then they are for a certain time they are available on the bus. So in our case, we use a pretty long time. We use 30 days. I mean, basically, you just have to see how much. This just changes how much storage Kafka will use. And now the nice thing is you can hook up any number of consumers, sort of like hang them off the event bus, and they are completely independent. So I can, at any time, I can add another consumer, and this will not affect in any way all the other consumers that are already there. And I can also pause a consumer, let's say for an hour, or for a day, or for 5 minutes, or whatever, and then have it continue from the same point that it left off. Which is has a lot of advantages, obviously, for deployment, for fixing bugs, and also all this is completely independent for the consumers. So we have, for example, we have one consumer that does the same thing that the old batch shop did, just take the events and put them in a MySQL database. So we can just continue running the old reports we already had configured. But then, the nice thing is that we can just go ahead and add new consumers that do very specialized things. So, for example, let's say I'm working on a game, and then we introduce a new feature, and we want to see we want to do an A/B test and want to see how this new feature is accepted or how it changes the behavior. So we could build a specialized consumer that just out of the whole event stream. So what we use basically one topic per game, very simply. So we have like 10 topics, and each topic contains all the tracking events for one game. So in this case, this consumer will just subscribe to one topic, and then basically throw away maybe 99 or 95% of all the events which are not relevant for this use case, and with the rest, do this custom analysis and maybe visualize it on a dashboard, for example, right? But the main feature is that you can develop this consumer independently from all the others. You can roll it out independently, and you can operate it independently from all the other teams. You don't need to get permission from anybody. You can just add it. Also, if you want to compare, let's say if you want to compare your game to a different game, you can just subscribe to 2 topics and do the comparison yourself. There's no need to get permission or go through any bureaucracy or something. It's just this is, I think, for us the best feature. And yeah, so I think we have currently something like I don't know, between 5 and 10 consumers in production. And most of those were built during the initial rollout, but now the teams have begun to sort of like to see that they now have the power to add custom logic that does something with the event stream, and that's very nice. And just a little bit more detail about the internals of Kafka, because what I like very much about Kafka is it's very simple. It's a very we had sort of like when we wanted to do this change, we looked at different systems. We looked at Flume, we looked at Kafka, and we looked at 1 or 2 others that I don't really remember.
Did you look at Gradle?
Perhaps. So we sort of like made a list. Okay, now there are these 5 possibilities, and then yes.
Just one question concerning your message bus, Kafka message bus. Do you have some number? How many events per second go into this bus?
115 in the minimum case.
150?
We have kind of 10 million users per day. The minimum thing that we track is the login code. I think.
No, but we actually the peak number is 5,000 events per second. But from what LinkedIn says, that a single Kafka broker can easily handle up to something like 200,000 per second. So we have a lot of headroom still.
One more question, and that the message bus sort those events automatically according to time zones, or is it just
yes, so I will answer this when I go to a little bit more about the details. So what Kafka basically does is keep one logical file per topic. Very simple. And so when the messages come in, they just get appended to this log. But it's a binary log. It's not a text-based log, it's just a binary log. So let's say this is the first message, takes up 70 bytes or something, and then there will just be the second message, and then the third message, and so on. And each message has an offset, which is the index of the start byte. Very simple, just a number. And so when you know the offset, you know the position in the event stream, right? Where you like the position until where you have already consumed the event stream and where you want to start again. So this is also something that the consumer has to keep track of itself. So Kafka basically is very simple. It's very dumb. It's just it's there. It's keeping track of all the events, and you can ask it, give me more events starting from offset X. Then you will get another batch of events. And once you have processed those, you can ask for more. If you crash, then it's your own responsibility to keep track of how far. Maybe if Kafka gave you 1,000 messages, you can either, if you crash in the middle, you can either completely ignore it and reprocess the whole batch next time, or you can update your internal offset count after each message or whatever. up to the one who builds the consumer. So, I mean, keeping all the messages in one big file would not be practical, so it is, in reality, it is a set of segment files. So what Kafka does is you can configure the segment size, and then I think default is half a gig, and this is also what we use. So once half a gig of messages have arrived and have been stored, Kafka just opens a new segment file and starts writing to the new segment file. And this is also, so again, it's really super simple. So the name of the segment file is just the starting offset, the offset of the first message in the segment file. Which means when you go into the Kafka installation and look at so each topic is a directory, and then if you list the files in the directory, you have basically something like sort of like an index of your message queue, right? Because you see valid offsets with timestamps when the segment was created. And what Kafka does then is, after the configured holding time, it will just delete the segment. Very easy. So in our case, after 30 days, the first segment goes away, and after the next maybe 2 or 3 hours, the next segment goes away. And so this is why it's so efficient, right? Because appending to a file is very efficient. It's also something that the access pattern is very well suited to spinning disks. Because you have you're just appending. It's easy. It's not randomly seeking across the whole disk. Deleting is super efficient because it's just kicking one inode, right? And normally, consuming the event stream is also efficient because normally, I mean, in the normal case, the consumers will be pretty much keeping up with the rate that events are produced. Otherwise, it will not make sense. I mean, if your consumer cannot keep up, then you have a different problem. Then you will fall more and more behind. So in the normal case, all the consumers are more or less up to date. So this means that the reads will normally be satisfied from, normally they don't even have to go to disk, they will be satisfied directly from the disk cache. Because it's the same file that was just written in the last 5 minutes, right?
Any experience with a lot of topics? Talking about 10,000 of topics. Is it still working, or because then we get random, like, go here, go there, and all this stuff? So does Kafka keep the file open, which will also be a problem when I'm talking about 10,000?
So I think that was discussed on the Kafka mailing list, and I think there are people who have really large numbers of topics, but it is not really covered by the intended use of the system. So they're not making any. LinkedIn is not making any guarantees about what will happen if you have 100,000 topics. So it would probably make sense to use SSDs in this case.
It makes always sense to use this.
Yeah, well, no, but this is actually this works pretty well with spinning disks. It's sort of like the way it's designed. It's designed to work well with spinning disks. But with a really large number of topics, it wouldn't probably not work as well. But there are no artificial constraints that Kafka puts on the number of topics. Yes, and all that I've told now is about Kafka version 0.6, which is already a year old now. So currently, I think the current version, I'm not sure if it has been released, is 0.7. And in the meanwhile, they have entered it into the Apache incubator. So at some point, I mean, it seems there's a lot of bureaucracy involved in getting into Kafka. Apache. So it's still in the incubator for a year now or something. So that it will eventually graduate to be a top-level Apache project and all that. And so it's also getting more complicated. I'm not really sure I like the whole direction that development is taking. So I think we just stick to the old version because for our use it's fine, and we do not need. I like what they. So we don't even use the whole feature set from 0.6. So we just have a single broker, right? And then you can also have multiple brokers. So if you have like more than 200,000 events per second, then you will have to do some like sharding across multiple brokers. And then you can have consumer groups which sort of like try to load balance the consuming between multiple. So we do not use all this complicated stuff, and it's, I mean, we have, so it's, I mean, I would say we have quite a bit of traffic already, and it's working well with a single broker. So the only thing we do, just in case that the broker machine breaks, and then we would, of course, would have a problem. So what we do is we rsync the segment files to a different machine. So in the worst case, we can just fire up a new Kafka on the new machine, and yeah, we lose rsync. Let's say it runs every 5 minutes, I think. So we might lose the last 5 minutes. I mean, we're not a bank, so it's not that big a deal, right? Then we'll lose some events.
Does Kafka has any type of replication built in?
Yeah, I think in the new release they have added something. Also, Kafka can run in the cluster setup with Zookeeper, which also, from my point of view, makes it much more difficult to operate, because then you also have to operate Zookeeper cluster. Of course, Zookeeper does not make sense on a single machine, so you need at least, I think, 3 or 5 nodes to make the Zookeeper thing work. So we decided to not use Zookeeper at all. And this means, on the flip side, that that our consumers have to take care of the offsets. Have to track the offsets themselves. But that's, I think, a pretty good trade-off for me at least. That I do not have to run Zookeeper. Others might see it differently.
But you also have the log files on the tracker, right? So
Yeah,
you re-import the
in the super worst case that the main machine dies and also the failover machine dies, then we would still have the log files.
Or the last 5 minutes you can re-index them from the log files as well.
Yeah, actually, so far it has never happened, and I do not really expect it to happen. It's just insurance. So, yeah. So the data is not that. I mean, we have 50 gigs of tracking data per day. So if we lose 5 minutes, we won't even. I mean, it's not probably not even worth the effort to try to find the data somewhere else. Maybe
Yeah, that's also mainly because this is just reporting data.
yeah.
It is not like
Yeah.
really user.
Right, the games will just continue to
transactions
work,
or
right? It's
something,
just that in the next days we know the reports will be a little bit off, maybe.
And the billing is done by Facebook for you, so...
Yes.
Sorry, Tim?
Yes?
As you said, you keep the events for 30 days. How much storage you got attached to the Kafka servers?
Well, it's pretty simple. 50 gigs per day times 30
Okay.
is about,
Okay.
what is it? 15 terabytes or something.
Okay.
And yeah, we have just, so we started to run this thing on Hetzner, and we had a big box with lots of disks, and now we have moved it to a local hosting provider in Berlin. But also it's nothing fancy, it's just a pretty ordinary machine with this.
Do you protect your trackers in any case, in any way? Or does everyone can DDoS them if they know the IPs?
Well, the trackers are they're very bare bones Nginx boxes behind load balancer.
Okay.
And there's I think there's also a firewall, but I mean basically it's just they're just static web servers, so it's they're not very easy to attack, right? There's not that
DDoS,
much you can
for
do.
DDoS you are really vulnerable.
You can sorry?
I can send you.
Yeah, denial of service is always possible. Yeah.
Okay.
No, but we haven't had any problems with that.
Do you do any authentication? So
No.
everybody could post.
In theory, yes. If you want to find out our
URL?
okay. No, I'm not going to post the URL, but it's easy to find out actually. So let's. Yeah, this is basically all I wanted to show. And still, if you have any other questions, I'm open for questions.
Sorry? Or didn't you use something like Google Analytics or something? Was there also kind of pop-up events and topics?
What was the question?
It's kind of a...
Yeah, why don't we use Google Analytics?
kind of...
or something like that.
Something like that.
Perhaps we could. I mean, this is really, we were a bit surprised because Kafka was the first thing we tried, and we had sort of like a plan to first try Kafka and then try the next thing and the next thing. But Kafka worked so well that we never got to trying anything else. We are pretty happy with what we have. There's always lots of ways you can do it, I'm sure. And we do not, so also what we do not do currently, we do not put any of the system metrics into Kafka. Right? Like CPU load or anything like that. It's just business metrics related to games. So we could also use it for that, but this has not been centralized so far. So each game is still there, so doing their own thing with Mania or whatever.
Google Analytics in theory is illegal to use in Europe because you are exporting private data from the users to the United States.
That might also be a problem. Also, we really like to have the data in-house. We like to have data on our machines, and then, so it's not just for security reasons, but it's also way more flexible in like, what we can do with it.
What do you use to render the graphs? And do you have a central way to do that, or does every team have to solve this problem?
Yeah, this is a good question. So one of the graphs, this one, like these two, they are built with Liberato, which I like very much. It's a hosted graphing service, which you just post the data, and they will generate graphs for you.
So you export the data to the US anyway?
In this case, yes, but it's just sort of like aggregated data. So we just post once per 10 seconds or something. So we aggregate, the consumer aggregates for 10 seconds and then posts the result to the cloud. And it's really nice because, of course, you can also do this yourself. You can also set up graphite or something else. But it was so super simple. It's just like you do, I think we actually do a curl, right? We have the numbers and we do a curl to the Liberato API. And
it's a simple image, right?
no, it's not an image. It's interactive, so you can switch the. I think it's HTML5. So you can select, you can shift, you can compare, you can do a lot. And it's the best thing is it's super cheap. So we paid. I just saw the last invoice. We paid $9.90 for March, I think. So I'm not sure how they can survive on $9 from Wooga. If they get a similar amount from all the other companies, they will have a hard time surviving. But I don't know. It's probably because they charge by metric, and we don't have that much. We have maybe 20 metrics, so that's why it's so cheap.
They don't charge per event, you said?
No, just
it's
by
usually
they charge a flat fee per metric per month. I hope they can survive because it's really handy. And so this is custom built. It's I think this is an Erlang game, so they have their own sort of like Erlang structures in memory. This is Mania. This I have no idea. This is also
like Jenkins.
yeah, it could be Jenkins. This is custom built Flash, and I think it's not even. It's probably driven by something like a Google spreadsheet or something that's updated manually. This one is also, if I'm not mistaken, it's also driven by Google spreadsheet that's updated once per day. This one is live. Nice. This one is also fake. I think it's also like handmade. So actually, like, a lot of the dashboards we have are not that changing that often. So I mean, for this thing, you could of course automate it, but you have just one data point per day. So. And it will go away after 4 months anyway. Right. That'll be a new one.
So actually, if somebody wants to have a party, he can go and change the right data and get the
he could try, but I think Jens would notice.
Okay.
It does not sound, the reports and the dashboard, something's wrong.
Okay. If you have any problems, because you mentioned at the beginning, and I have heard it on every Wooga talk, that you have all these different teams and they use whatever they like at the moment. They have Erlang, you have Ruby. I don't know if
But
that's
it's not,
something else.
so it sounds a bit wild, right? And it sounds a bit like, oh no, in 2 years we will have this complete zoo of every technology that was ever invented. But that's not actually the case, because we try to encourage knowledge sharing between the teams. And so if one team tries Erlang and they see it works well or it doesn't work well, they tell the others, and so the knowledge spreads in the company. And we also, so in what we do basically with each new team, it's a greenfield development starting from scratch, and we try to, from the other games that have already been done, we try to learn. So not necessarily take code from the other games, but more like concepts, ways of doing stuff, learnings. This is the main thing we transport from game to game. And yeah, it could become a maintenance problem. If all the Erlang guys decided to leave, then we would be stuck with an Erlang backend that nobody knows how it works, right? And we would have to find new Erlang guys to run it, but it hasn't happened so far.
Now, have you got problems with hiring Erlang guys?
Yes.
Because I think that's very okay.
So basically, when this one team decided they wanted to do Erlang, they didn't even know it very well themselves. So we hired one guy from Norway, and he had worked in Stockholm before. So all the good Erlang guys are in Stockholm. And this is the only one we succeeded in luring from Stockholm to Berlin so far. So the other Erlang knowledge we have sort of like built up in house, and no, but it can be difficult. So this is also why probably we will not. I mean, if the next game decides they want to do it in Haskell, we would. If they really want to do it, they can do it, but we would probably not encourage it, right? So would not encourage them to choose the most exotic thing they can think of.
And the dashboards, are they spread on how many developers do you have?
So there are now, I think, 180 people working at Wooga. Maybe
I guess there are a lot of rooms. So
maybe half or a third are developers.
And the dashboards, are they organized in every room, the same dashboard?
Yeah, so each team has its own room, more or less. At least if we have enough rooms, then each team gets its own room, and dashboards are hanging in the rooms. And so I didn't even know how many we had, so I just went around and took some pictures.
What will more work for you, like developing the central view service or the dashboards?
I think the dashboards are more work because the Kafka was really, it took maybe a month all in all just to replace the old cron-based thing by the new message bus and having the consumer that does the same thing as the. But now we have this foundation in place, and we can build a lot of new cool stuff on this foundation that we could not build before easily. So the effort for building custom stuff is more spread out over time and spread out over multiple people. So we do not actually track it. So I do not know how much time we spend on that because.
You said also in the beginning, like, what was it that you said the second version that all finance?
No, this was in my work before Wooga.
And
so we never had.
Yeah. Are you running sometimes, like, if the game really starts off very successful, are you running them into scaling issues? I mean,
Of
I
course,
can understand
yes, we
like,
do. Yeah.
A lot of games that this scales quite well, like, because each game has to scale on its own.
Yeah.
But then still you can have like.
Of course. I mean, when we are looking forward to running into scaling issues because this means the game is successful, right? The worst thing is that can happen is that we put it live and it never has any scaling issues, and this means it's a complete failure.
Okay,
so
problem to have. Right?
Yeah. Basically, so the goal for each game, like the minimum goal is 1 million players per day. This is what we need to make it commercially viable, because they're paying very little. 90% are not paying anything at all. So you really need a huge number to make it viable. And so this is sort of like this 1 million players per day is sort of like the number we use also when we design the architecture. But of course, we always hope that it will go much higher, right? Then it will be like a hit, like draw something. But this is hard to plan. Hard to plan for. You cannot just go ahead and plan the whole infrastructure for 100 million players per day, and it will never happen. So yeah, we run into scaling issues, and then we solve them once we have them.
in the small team,
Yeah.
or are there some specialists you then take?
No,
Because
it's all.
who have managed like scaling games?
No. It's all.
Okay.
It's all the responsibility of the team, and that, in this case, it means 2 or 3 guys, which are the backend developers and the backend engineers on this team.
And is the team also killing games if they don't succeed?
That's normally not the team. That's normally the more like the CEO who says, "No, we are not going. This is not. We feel we can spend the resources better on other stuff." So it has not happened that a team has decided on its own to quit.
You are showing just business data on the dashboards as well, and why you don't use your reporting infrastructure for aggregating all the stuff, and why you have several systems.
Yeah, that's mostly for historic reasons. I mean, this new tracking infrastructure is pretty new. It was just introduced a few months ago, and we have not found the time to. I think it would make sense to put more on this thing because it can handle a lot more data. It's working well. It's very stable. It never crashed so far. So yeah, we probably should. So like, it's always something even more important to do on the game scene.
You only have 2 systems, right? This logging stuff, reporting, and this Kafka thing.
Yeah, I consider that one system.
Okay.
The tracking in Kafka, so like this is what we call the tracking system, tracking reporting system.
Yeah.
And then for each game we have a different installation, the production system for the game. They are spread out over multiple locations.
Because always a danger with tracking, it's a lot of systems. And so we at the Pro, we had 5 different systems where the tracking data goes, right? And it's kind of a zoom. Different trackers, and then we're a web application. There's a lot of also cookies and stuff. We send to other providers. It's kind of a help.
Yeah.
But you always track from what's coming into the server. You don't track.
Well, we also track from the client, and the client can also. This is why it's returning an empty GIF, so we can also just include it in the web page, or I mean the games are built in Flash normally, so the Flash will just insert a track like dynamically into the tracking pixel. Actually, I think 90% of the tracking calls are coming from the clients, so from the players, and just sort of like payment confirmation and stuff. This is actually tracking calls that the server makes. Yeah, then if there are no more questions, I would just briefly like to mention that we are, of course, always looking for good engineers. Not only Erlang, I mean, we're just looking for good engineers. Yeah, even if you do Haskell, please apply. And I put here some links just for the 2 main technologies that I mentioned. This Kafka, with the Kafka page, which also has a very good sort of like high-level paper.